In this video, we're going to be going over and practicing taking derivatives. Okay, so say that you get a question on a test and it says, find dy dx by implicit differentiation. We're going to do two like this. Okay, so say you are given this function. Whoops. Okay. And you are told that you need to find dy dx by implicit differentiation. All right, so we're going to take the derivative of the first, like we normally would with derivatives. Derivative of 9x is 9. Derivative of 7xy is going to be 7. Derivative of x is 1. Derivative of y would also be 1, but you have to take the derivative of y with respect to x as well. Then you're going to bring down the power, subtract 1 from the power. Derivative of 4 is a constant, it's always 0. So let's clean this up a bit. Oh, forgot that we're taking here we go. You also have to take the derivative of y with respect to x. Okay. Now, we need to move these over to the other side because we need to isolate dy dx. That's what we're looking for. So let's plus this guy over and subtract this guy over to the other side. So we're going to have plus 8y to the 7th dy dx minus 7 dy dx. Okay. And then let me bring this a little bit closer here. And this was just what was left on the left-hand side. Now, since we need to isolate dy dx, we have a common factor here in each one of our parts on the right side. So we're going to take dy dx out. We're going to have 8y to the 7th minus 7. This side stays the same. And then to complete the isolation of dy dx, we just divide this away. And then that is our derivative. Okay. Now let's do one more like that. Say we are told to find dy dx by implicit differentiation of the function cosine x plus y equals x. Let's do x. Okay. So we're going to need to take the derivative of cosine. The derivative of cosine is negative sine. You leave the inside as it is first. Then you take the derivative of the inside. This is called a chain rule, and that's because there are links in our chain, right? The first link was taking the derivative of a sine. Then you write the rest as it is. Then you take the derivative of what's inside. Now, since we are taking the derivative of, we're trying to find dy dx, when we took the derivative of y, it was 1, but we also need to put dy dx equals derivative of x is just 1. Okay, so now let's bring this over to the other side. All right, I'm going to put a plus or a minus. There we go. Minus this to the other side. So we're going to have, no, we're not plussing. It's just joking. We're going to divide. So it's going to be 1 Actually, you know what? It would be easier if before we divide, well, let's just do it this way. Negative sign x plus y. We're going to divide that away. Okay, so now we have 1 plus 1 dy dx equals 1 over negative sign x plus y. And you could leave it this way because the there's another way you can take it too, and I'll show you that in a second. 1 over sine is, we have negative cosecant x plus y. Okay, now we also need to subtract away this one. So this could be one of our answers. That could be one of our answers. I want to show you though that you can get more than one answer for these derivatives. So let's start again. Cosine x plus y equals x. Okay, so derivative of cosine, the way we take the derivative is the same. The only thing that changes is how you choose to simplify your answer. So we have negative sine, the angle stays the same, and then we take the derivative of the angle, which would be 1 plus 1 dy dx equals 1. Okay. So then what you would do is subtract, divide 1 divided by 1 plus 1 dy dx equals negative sine x plus y. Oh, you know what? Let's do it this way. So if we want to do it this way, we should first distribute this sign, x plus y. Okay. So we're going to do x plus y times 1 is just negative sine x plus y. And then we have, we're going to add, so it's going to be negative sine x plus y dy dx equals 1. Okay? And then what you can do is, let's bring this over some. We'll have 1. Let us now say plus sine x plus y dy dx. So we'll plus this over. And then we have negative sine x plus y. And let's subtract this 1. Okay? And so now we have negative sine x plus y minus 1 equals sine x plus y dy dx. Now to further isolate, because that's what we're trying to solve for, so we need to isolate dy dx. So we're going to go sine x plus y. And then that is going to be our derivative. And another reason I wanted to show this way is because there seems to be sometimes an uncontrollable urge to cancel like things. Like this, it just looks so perfect, right? Don't do it. Don't do it, because you're subtracting. So if you're adding or subtracting, if you're taking something away from this, you can't cancel. The only time that we can cancel is if we had a common factor and we pulled it out front, which I think that we're going to see an example where that does happen. So this could be another answer. Now see, these two answers, this one and this one, they look totally different, right? But they're not. They're the same. Okay, let's do another one. Okay, let's do find the derivative of, so now we'll do y equals the ln, the natural log, of x squared minus 16. Now the first thing I want to do when I see something like this is rewrite it so it's more in a better form to have the derivative taken of it. So I have a few things going on here. I'm going to rewrite this as, because x squared minus 16 square rooted is the same as x squared minus 16 to the half. Now, by the rules of logarithms, if I have an ln of something to a power, right, which is what this is, it's the ln of something, this would be a, and that would be the power, then I'm able to bring the power down and make that a multiplier. Okay, so that's what I'm about to do right now. So we're going to have 1/2 ln of x squared minus 16. I have not started taking the derivative yet, so you will see that my, oh, stars. Okay, that did have the notation. If I don't want to have this saying y prime, because that means I've already started taking the derivative, and I haven't. So now I'm going to start taking the derivative. Okay, so we have 1/2. When you take the derivative of a natural log, you just put the entire function as it is in the bottom, and then you take the derivative of that function, the inside, on the top. Now we need to go ahead and multiply that, so it's going to cancel. So our derivative is going to be x over x squared minus 16. And that is our derivative. Okay. Let's do another one. Let's do y equals the ln of x squared plus 3. Now we're going to do the same thing with this one that we did with the last one. We're going to rewrite it to make it more in a better form to be having the derivative taken of it. So first thing we need to notice with this is that this is a product. It's multiplication going on here. So what we can do, well, let's go ahead and rewrite the first part. We'll do it step by step. So we have x squared plus 3 to the 1/2 times x. So now it's a little bit more obvious that we also have a product, right? So now we're going to take the ln of x. Well, we're not going to take the ln of x. We're going to split this up to be, because the properties of logs say that if you have ln of a times b, you can write that ln of a plus ln of b. And this is going to make taking the derivative so much easier. So it's really important to know the properties of logs, because they're going to help you a lot. And then remember, we just went over the last property of logs that says if I have the ln of something raised to a power, I can bring that power down and make it a multiplier. This is supposed to be plus. Okay, now we are going to start taking the derivative. After all, you'll see simplify, simplify, simplify before you begin to take your derivative, and that'll make things so much easier. Okay, so the ln of x, remember when you take the ln of something, you just put the function in the bottom and the derivative of the function in top. 1 over x will always, always, always be the derivative of ln of x. It's one of those things you can just memorize, so you can do it without even having to think. Okay. Then we have x squared plus 3, and then the derivative of 2x. Now, normally I would be like, cancel those. However, we're not going to do that because we need to get a common denominator here, and then we'll see how our canceling goes, okay? So before we start wiping stuff out, let's get a common denominator. Okay, so the x squared plus 3 is going to be multiplied over here because there's already an x. So if I put another x there, which technically is being done, it would just cancel. So we don't need one of those there. Then we have this right here is going to get an x. Okay, and then on the bottom we have x times 2 x squared plus 3, and that 2 is in the denominator, so we just went ahead and sat them down there. Okay, so now we have, let's make this a little bit neater. And we can remove the parentheses actually now because everybody's just being added together on the top. Okay, so now we'll see that our 2's can cancel. And then we are going to go ahead and add everything up. So we have 2x squared plus 3. All over x times x squared plus 3. And that is our derivative. Okay. Let's get some more practice. Okay. So what if you have a function that is 5e raised to the power of 2x squared? What would you do? Feel free to pause the video at any time and try to work these out yourself too. Okay, so 5 is just a multiplier. He's a constant multiplier, so he's not going to do anything. We're not going to take the derivative of him. The e, though, the derivative of the e is always e to the whatever. So we have e 2x squared. That doesn't change. But then you have to take the derivative of whatever e is raised to. And the derivative of 2x squared is 4x because you bring this down to be a multiplier. So now our answer is 20x e 2x squared. Oh, and I forgot. There we go. Make sure you don't forget your notation. Okay, let's do another one. Find the derivative of f of x equals x cubed e to the x. Okay, first thing we need to recognize here is that this is a product. So you have to use the product rule. Now, when you are doing the product rule, you take the derivative of the first times the second as it is, plus the derivative of the second times the first just as it is. You'll see what I mean in a second. Okay, so the derivative of the first is 3x squared times the derivative of this, or not the derivative, excuse me, times the second, just as it is, plus the derivative of the second, which we know is just e to the x times 1, because you are taking the derivative of the power that e is raised to, times the first, just how it is. Okay, let me make this a little bit neater. Okay, so now we have 3x squared times e to the x plus, we'll say x cubed, just bring that in front, times e to the x. All right, so now we have 3x squared. Well, you know what we can do? Since we have a common factor of e to the x, we can pull him out. What else do we have a common factor of? We also have a common factor of x squared. So let's pull those out. X squared, e to the x. Then what do we have left? 3. We don't have an x squared because we pulled it out. We don't have an e to the x, so we take it out. Then we put the plus sign. We have x cubed. Well, that means if we took x squared out, we have 1x left. And then e to the x, well, we took that out. So this is our derivative. All right, let's get some more practice. Let's say we have f of x equals e to the x 1 plus 5x squared. Now there's more than one way to climb a tree, but I think it's good for us to get practice with, I'm going to do this in red, with different ways to take derivatives. So we'll do the quotient rule. And the quotient rule says you take the bottom, whatever it is, and you square it, and you put him on the bottom. Then you put the bottom, just how he is, the derivative of the top, minus, so when we're taking the quotient rule, it's minus, product rule is plus, minus the derivative of the bottom times the top, just how he is. All right, let's do this. So we have the bottom squared. Then we just copy the bottom again. And then we take the derivative of the top, which we know is e to the x. Derivative of x is 1 minus, oh, I don't know if I'm going to have enough room. I'm going to put this over here. Oops. For now. Oh, stars. Okay. You know what? I'll just rewrite it. Let's finish taking this derivative. I'll rewrite it on the next one that we do that's like this. Okay. So where was I? So now we're doing derivative of the top, or excuse me, derivative of the bottom now. So the derivative of 1 plus 5x squared is 10x. That's because we take 1 is a constant, derivative is 0, 5x squared, bring that down. That becomes 5 times 2 times x. That's 10x. Times the top, just how he is. Now, we need to go ahead and distribute these things together. So we have 1 plus 5x squared 2e to the x minus 10x e to the x all over 1 plus 5x squared squared. Okay, now if we look at the top, we have a common factor that we can pull out. We also have an x that we can pull out. No, we don't, because we have that 1. Just joking. So we're only going to take the e to the x out. So in order to take a factor out, it has to be a factor of every single thing. So if I wanted to take, now this e to the x is a factor of this, because it would have been, if I had fully distributed, it had been 1 e to the x plus 5x squared e to the x. So we can take an e to the x out because he is a part of everybody. So e to the x, then we have a 1 plus 5x squared minus 10x all over 1 plus 5x squared squared. Man, don't forget to write down that you're taking the derivative. All right. Now let's do some more. Okay, so what if you got something that said, find the derivative of the function f of x equals 2x cubed plus 2x squared minus 3. Well, we can go right into taking the derivative of this. This is going to be 6x. So you bring that down and multiply it. Bring this down and multiply it. And then you have to say, remember for power rules, if you have something, well, let's do, if you have x raised to a power, the derivative of that is n to the x n minus 1. So right now I have 2x cubed, that's going to become 2 times 3, and then n minus 2 would be 2, okay? So 6x squared plus 4x minus 0. All right, so that's your derivative, and then you can just, you don't need that part. So that's your derivative. Now, what if we have this? F of x equals 6x cubed minus 4 sine x. Well, f prime of x is going to be 6 times 3 x squared minus, well, 4 is just a multiplier. Derivative of sine is cosine of x. And then we would also take the derivative of the angle, but x is just 1. So then let's make this pretty. 18x squared minus 4 cosine x. That's your derivative. Okay, so now we are going to use the product rule to differentiate this function. Remember, we said the product rule is the derivative of the first times the second plus the derivative of the second times the first. Okay, so if you have a test that says use the product rule, to differentiate this function. And so I'm going to write it down here so we have more room. G of x equals x to the negative 5 cosine of x. Okay, so it's telling you to use the product rule because this is a product. But it won't always tell you that. So you're going to have to practice so you recognize them. All right, so we're going to go right into taking the derivative. So we're going to take the derivative of the first, which is going to be negative 5x. Now, negative 5 minus 1 is negative 6 times the second, just how he is, plus the derivative of the second. Well, the derivative of cosine is negative sine. And then we would take the derivative of the angle, which would be 1, times the first, just how he is. Now we need to put these together. So we have negative 5 x to the negative 6 cosine x minus sine x to the negative 5th. Okay, so we have here a common factor of x to the negative 6th. And I know if you're like, hold on, what do you mean it's x to the negative 6th? Well, if you have a number line, and here's our negative side, here's our positive side. If you go 1, 2, 3, 4, 5, 6. Well, negative 5 is greater than negative 6. So negative 5 includes negative 6, right? It's just like if we have 1, 2, 3, 4, 5. Okay, 5 includes all of the numbers before it. So when we pull this out, it's going to include all of the numbers before it. So we're going to pull out an x to the negative 6. And then we have negative 5 cosine of x minus sine of x. And that is our derivative. You could also write it negative x minus 6 is positive. If you want to have this positive, you could just pull your negative out as well. So you could do either one of those. Okay. Now, what if you have a problem that says use the quotient rule to differentiate? The function f of v equals 8v divided by v cubed plus 8. Okay, so we said that the quotient rule went like this. Not derivative. The bottom squared. Then rewrite the bottom just how it is. Take the derivative of the top minus, well, let me do it the way I did before. Minus the derivative of the bottom, because you could switch these up because it's multiplication, but you can't switch up what you do before and after. Otherwise, you're going to get opposite, like your signs will be wrong and it'll just be wrong. So minus the derivative of the bottom minus the top as he is. All right, so let's do this. So we have f of v equals v3, or v to the third, I should say, squared. Now we're going to rewrite the bottom as he is. Take the derivative of 8v, that's just 8, minus, the derivative of the bottom, which is 3v squared, derivative of 8 is 0, times the top, just as he is. Then we're going to put this together, okay? So we're going to have 8v cubed plus 64 minus, and that is going to be 24v cubed, all over still v3 plus 8 squared. I forgot my notation. Don't forget your notation. Okay, and then 8 minus 24 is going to be minus 16 v cubed plus 64 all over, whoops, v3 plus 8 squared. And then this is your answer. That's our derivative. Okay. And then let's do find the derivative of the function sine of x divided by 8x plus cosine of x. Okay, so we're going to use the quotient rule with this one too. So we're going to say f prime of x equals 8x plus cosine x squared all over, well, we're going to put the bottom right here just how he is, copy him, and then we're going to take the derivative of the top. Now the derivative of sine is cosine. Subtract derivative of the bottom, 8x. Derivative of 8x is 8. Derivative of cosine x is sine x. Times the derivative of the top, just how he is. All right. Now we need to combine these. So we have 8x cosine squared x. Oh, well, you know what? That'll be 8x cosine x plus cosine squared x. And then let's distribute this before we distribute the minus sign. So we're going to have 8 sine x plus sine squared x. All right, now if you look here, we have cosine squared x plus sine squared x. And if you remember, that equals 1. Let me finish this. This equals 1. So we can get rid of those and make that a 1, a plus 1. So that'll give us 8x cosine x minus 8 sine x plus 1 all over 8x plus cosine x squared. And this is your derivative. All right. Let's do one more with the trig functions because they're really good to practice. Okay. All right, so what if they tell you to find the derivative of the trigonometric function f of t equals t to the 5th power times tangent 4t. So again, we need to recognize that we're going to be using the product rule for this to differentiate it. So f of t equals derivative of the first times the second, just how he is, plus the derivative of the second, which is going to be, derivative of tangent is secant squared. Now you write the angle just how it is. We're going to have to chain rule derivative this. So then you take the derivative of 4t, which is just 4, times the first, just how he is. Now let's put these together. 5t to the 4th, tangent 4t, plus 4t to the 5th, secant squared 4t. Okay, now we have a common t4 that we can pull out. That's going to leave us with 5 in this, tan 4t, then a plus, and then a 4 secant squared 4t. And that is your derivative. Oh, that's pretty cool. Okay. Oh, you know what? Hold on a second. 5 tan 4t. Yep. Okay, we had it. Okay. Thought I missed something, but I didn't. That's good. All right. Then let's do another. Find the derivative of the function f of s equals s cubed plus 4 to the 5th power. All right, so we're going to go straight into taking our derivative. Now we have to take, remember, the derivative of the power first, so 5. The inside just how it is, and then n minus 1. And then we're going to do the derivative of the inside, which is going to be 3s2, because the derivative of 4 is 0. So we're going to have 5 times 3s2, which is 15s2, s3 plus 4 to the 4th. And that's your derivative. Okay, and then let's do another. Find the derivative of the function f of t equals 1 plus 3t to the 4/7. All right, so first thing we're going to do is take the derivative of the power. So bring that down. Now, when you do the minus 1 for this one, you're going to say 4/7 minus 7/7, right? That's 1. So it's going to be negative 3/7. Right? Okay. Then you have to take the derivative of the inside, which is 3. So we're going to multiply this 3, it's going to get multiplied to the top because he's in a numerator too. He has that invisible 1 under him. So that's going to be 12/7, 1 plus 3t to the negative 3/7. And there you go. That is your derivative. Oh, you know what? We could also do this. Since this guy is negative, we could do it like this. We can just put him in the denominator and make him positive. because that's all that means, right? Is that if we were to bring him up top, he would just be a negative 3/7. So we'll just go ahead and leave him. Either way, either one of these is fine, but we'll do it like that. Okay. And then let's do another. Find the derivative of the function y equals negative 3 sine 3x. All right, so we're going to take the derivative of the sine first. This negative 3 is just a multiplier. He's just coming along for the ride. He doesn't do anything. So we have the derivative of sine is cosine 3x. Angle stays the same. Then we have to chain rule derivative it and take the derivative of 3x, which is 3. That means our derivative is going to be negative 9 cosine 3x. Okay. Then let's do another. Y equals cosine 5x to the 6th power minus 8. All right, so we're still going to take the derivative of the cosine first. So y prime, so the derivative of cosine is negative sine. All of the trig functions that start with c have a derivative that's negative, every single one of them. Okay, and then we're going to write the angle just how it is. Then we take the derivative of the inside angle, which is going to be 30x to the 5th. And then we're going to put this together. Negative 30x to the 5th, 5x6 minus 8. And that is your derivative. Okay. Let's do another one with a trig function. So find the derivative of f of t, 3 secant squared, 7 pi t minus 1. Okay, so I think it's really important to do this one because you need to understand the order of operations. So I remember it using the acronym PTA. You take the derivative of the power first, then the trig function, then the angle. Let's see how that looks. So we're going to have 3 is just a multiplier. So our 2 is going to come down. And we have secant. This would have an invisible 1 right there. We write the angle just how it is. Then we take the derivative of the trig function, which is secant. Well, the derivative of secant is secant, and then you have to write your angle again. Tangent. Then you have to take the derivative of the angle, which is 7 pi, because the derivative of 7 pi t would be 7 pi. Derivative of negative 1 is just 0. Then we need to put everybody together. So we're going to have, we have 6 over here and 7, that's 42 pi secant squared, because we have these two, 7 pi t minus 1, tangent 7 pi t minus 1. Oop. And that is our derivative. Okay. And I hope that this was helpful. Keep practicing.